Quantum computers have the potential to exist in multiple places at once, thanks to their ability to process information across parallel universes. But could this extraordinary power be impacting more than just computation? What if quantum technology, like Google's latest breakthrough with its Willow chip, isn't just solving problems, but altering the very fabric of reality? Scientists are grappling with the possibility that quantum computers could be stretching and bending the rules of space and time, with consequences we don't fully understand. For decades, quantum computing has been seen as the key to unlocking humanity's greatest mysteries, from revolutionizing AI to advancing medicine and weather prediction. Unlike traditional computers that work with binary data, quantum computers use qubits, which can exist in multiple states simultaneously. This unique feature enables them to solve complex calculations at astounding speeds, tasks that would take traditional supercomputers thousands of years to complete. But what if these powerful machines are inadvertently doing something more than just solving equations? What if they are tipping the scales of reality itself? In 2019, when Google's Sycamore processor achieved quantum supremacy, scientists believed they had taken a monumental step in computing. However, it now seems their success might have triggered a series of anomalies in our perception of the world. Early on, these disturbances were subtle, unexplained glitches in data and odd behaviors in quantum simulations. As quantum computing progresses, however, these glitches have become increasingly difficult to ignore, suggesting that reality itself might be undergoing alterations as a result of quantum operations. What if our world is being quietly influenced by quantum computers? Decisions we make, from the stock market to healthcare, may already be shaped by these invisible quantum algorithms. It's possible that we're living in a reality subtly manipulated by quantum processes designed and executed in ways we can't even perceive. As quantum systems become more interconnected, reality could be morphing daily, with immense, unpredictable implications. Even more troubling is the notion that time itself could be subject to manipulation. Some researchers have observed strange patterns suggesting that future quantum calculations could influence past probabilities, bending the timeline. Imagine flipping a coin, and after it lands, the outcome is subtly altered, as if the past has been reshaped to increase the chance of that result. Could this be happening without our knowing? Are quantum computers responsible for certain inexplicable phenomena, the Mandela effect on a larger scale, even distorting shared memories? The most horrifying possibility is that we may already be beyond the point of no return. Once quantum computations begin shifting reality, reversing the effects may be impossible. Despite this, global tech powers and governments are accelerating their quantum endeavors, seemingly oblivious to the enormous risks at hand. Reports suggest that some have already observed anomalies tied to quantum experiments, yet rather than halting progress, they are doubling down, continuing the pursuit of quantum supremacy. Will quantum computers, which can process information in multiple states thanks to superposition, soon lead us into an era where glitches, time distortions, and reality-altering occurrences are commonplace? Quantum entanglement, where particles become linked in ways that defy distance, suggests that multiple quantum events occurring far apart can still exert influence over each other. As entanglement grows in power, it's possible that quantum machines could substantially warp whole systems of information. However, the key issue is the unprecedented scale at which these quantum computers perform. As they grow more advanced, they might unintentionally open doors we cannot close, tearing apart realities or realities themselves, one quantum computation at a time. Some theorists even warn that this could be a cyclical issue, perhaps the reason why previous high-tech civilizations may have mysteriously vanished. Could these anomalies, from vanished societies to erased civilizations, be the result of quantum experiments gone wrong? What if we're repeating history? We are standing at a crossroads. Will we understand how to harness quantum computers before it's too late? Or are we pushing forward with blind enthusiasm, hoping we can control forces that by their very nature defy our control? Time will reveal whether quantum computing is our greatest gift or the key to our existential destruction. The choice ahead is fraught with uncertainty: to forge ahead into a new era of discovery, or to halt and reflect before rewriting everything we know. What do you think? Are we unlocking the universe's deepest mysteries, or are we playing with a force capable of altering reality itself? Per 47 secondi, they can exist in two places at once, and that's precisely what grants quantum computers their extraordinary capability. These machines don't simply operate in one universe. They simultaneously perform calculations across an endless number of parallel realities. Now imagine if the reality we take for granted isn't as fixed as we assume. What if quantum computers, with all their staggering potential, are responsible for the unprecedented power of Google's latest quantum chip, Willow? So potent, in fact, that it's forcing physicists to re-examine the very fabric of existence. Some scientists now worry that these devices are not merely solving complex problems. They might actually be altering reality itself. And the most unsettling part is that we may not have the means to reverse it. For decades, researchers have dreamed of a future where quantum computers unlock the universe's deepest secrets. Their promise spans from turbocharging artificial intelligence and transforming medicine, to revolutionizing cryptography and even refining weather predictions. Quantum technology has long been hailed as the ultimate tool to overcome humanity's greatest challenges. Unlike classical computers, which crunch data in a binary dance of ones and zeros, quantum machines operate using qubits, particles that can embody multiple states simultaneously. This remarkable property, known as superposition, enables them to perform computations in seconds that would otherwise confound even the most advanced supercomputers for millions of years. But what if these quantum marvels are doing far more than just speeding up calculations? What if, by decoding the mysteries of quantum mechanics, we've inadvertently unlocked a power we were never meant to harness? Consider the landmark moment when Google's Sycamore processor achieved quantum supremacy, solving a problem in just 200 seconds that would have taken a conventional supercomputer 10,000 years. At the time, it was celebrated as a transformative milestone in computing. However, recent findings hint that this breakthrough might have been the initial step toward reshaping the very structure of space and time. At first, the anomalies were subtle, minor glitches in experimental data and tiny discrepancies in quantum computations. But as quantum systems grew more sophisticated, these distortions became impossible to ignore, suggesting that the very rules of reality might be bending under the strain of quantum processing. Imagine the ripple effects of quantum computing permeating everyday life. What if these devices are already reshaping our world in ways that elude our perception? Consider the possibility that decisions made in boardrooms and hospitals alike are being subtly steered by quantum processes working behind the scenes. From stock markets to healthcare systems, quantum computing might be influencing outcomes without our conscious awareness. The inherent interconnectedness of quantum systems raises a daunting prospect: that the reality we experience is being continuously tweaked by algorithms operating on scales far beyond our control. Yet for most of us, the inner workings of these quantum black boxes remain an enigma. Even more disconcerting is the notion that quantum computers might be warping time itself. Some physicists, running advanced simulations, have observed an eerie phenomenon. Future computational outcomes seem to be retroactively affecting past probabilities. In layman's terms, it's as if quantum machines are reaching back in time to adjust conditions even before a calculation concludes. Picture flipping a coin. Traditionally, it lands either heads or tails. But what if, after the coin lands, a quantum effect subtly shifts the odds so that it appears the coin was destined to land on heads all along? Several researchers contend that this isn't mere speculation, but a process that might already be occurring, not just in controlled experiments, but in the very fabric of our reality. Reports from quantum computing laboratories add to the unease. Researchers have documented bizarre occurrences that defy conventional explanations. Equipment malfunctions with no clear cause, particles behaving in unprecedented ways, and data emerging where none should exist. These aren't isolated quirks. As quantum computers grow more powerful, these distortions occur with increasing regularity, as if reality itself struggles to maintain its consistency. Then there's the curious case of memory discrepancies, often referred to as the Mandela effect. Large groups of people recalling historical events or details differently from how they are recorded has long been dismissed as faulty memory. But what if these collective misremembrances are not mere coincidences, but the result of quantum computations shifting us subtly between parallel realities? If so, how many times have these shifts already taken place? The most alarming implication is that such changes might be irreversible. Even if every quantum computer were to be shut down tomorrow, the alterations already etched into reality could persist, or even continue to evolve on their own. Yet, rather than pulling back, the world's leading governments and tech giants are intensifying their quantum research. The United States, China, and the European Union are investing billions in the race toward quantum supremacy. The logic is stark. Control over quantum computing means control over the future. Leaked documents suggest that some governments have even observed unexplained effects linked to quantum operations. Aware of these anomalies, instead of halting progress, they are redoubling their efforts. Some experts now fear that we might have already crossed an irreversible threshold. To understand this paradigm shift, consider how traditional computers function. They use bits, the smallest units of data that exist in a binary state, either on or off, representing the familiar ones and zeros. Every program, website, and game is constructed from these binary elements, which switch back and forth at phenomenal speeds. Quantum computers, however, introduce qubits. Unlike bits, qubits are not confined to two states. They can embody multiple states concurrently, thanks to superposition. Visualize a coin spinning in midair. It's simultaneously showing both heads and tails. That is the essence of a qubit. This capacity to harbor numerous possibilities concurrently endows quantum machines with the ability to process immense volumes of data at speeds unimaginable to classical systems. A task that might take traditional computers millions of years can be completed in mere seconds by a quantum processor. And yet, superposition is only part of the story. Another enigmatic feature of quantum computing is entanglement, the phenomenon where qubits become inextricably linked. In this state, a change in one qubit instantly influences another, regardless of the physical distance separating them. Imagine rolling a pair of dice that seem to coordinate their outcomes, no matter how far apart they are. Entanglement enables quantum computers to tackle extraordinarily complex problems and execute calculations once deemed insurmountable. These dual pillars of quantum power, superposition and entanglement, offer unprecedented computational strength, but they also thrust us into a realm of uncharted consequences. As demonstrated by breakthroughs like the Sycamore processor and the Willow chip, these devices may be capable of far more than just solving problems. They might be beginning to manipulate the very laws that govern our reality. So what happens when these quantum machines push the boundaries of physics to their limits? What if, as their power grows, they begin to influence reality in ways we never anticipated? Some scientists warn that we could soon witness reality glitches. Instances where events contradict established history, time appears to flow backward, and the cause and effect relationship unravels into chaos. There may even be shifts in historical records, as if the past is being rewritten in real time. Even more disquieting is the possibility that an entire civilization could be erased from existence. What if ancient advanced societies had tapped into quantum mechanics long before us, only to have their own achievements inadvertently trigger their downfall? Mysterious vanishings, cryptic legends, and sudden losses of entire cultures might not be mere myth, but the recurring consequence of tampering with quantum power. This brings us to the ultimate crossroads. Should we press forward or pull back? As quantum computing accelerates, we are forced to confront a profound dilemma. Are we on the verge of unlocking the deepest cosmic mysteries, or are we recklessly dismantling the very framework of our existence? If the dire warnings from physicists prove true, we might already be standing at the precipice of an irreversible transformation, a quantum shift that could forever alter reality as we know it. The decision now is ours. Do we continue advancing despite the mounting risks, or do we halt progress before we cross a boundary from which there is no return? Perhaps the most unsettling question is this: if reality has already been rewritten by these quantum processes, how would we even detect it? So what do you think? Are we about to witness a quantum revolution that will redefine our future? Or are we hurtling toward an existential catastrophe of unfathomable proportions? Drop your thoughts in the comments below. Do you believe that quantum computing is the key to a brighter future? Or is it the greatest threat humanity has ever faced? And if you want to stay on top of groundbreaking discoveries like these, be sure to subscribe and turn on notifications, because what comes next might just change everything.